All right, so first off, some stuff we've been doing lately. If you saw this, you could tell me that it's in what form? General form. Do you know how to get it to be factored form? Well, you factor it, but this one won't be able to factor. You could figure that out pretty quickly. If it had been able to factor and it was like x plus 3 and x plus 1, it can't because this outside and inside won't make 6. But if you did do that, you'd be able to find the roots pretty easy. You could just like set this equal to 0, set that equal to 0. All right, some other stuff that you should know. Why do we constantly set the y equal to 0 on these? Because we want to find the x-intercepts, or the roots, also known as the zeros. Okay, and you can use the quadratic formula for this. Would you please put these numbers into the quadratic formula? And if you need a calculator to finish it, go ahead. Because even though this one may not graph nicely or factor nicely, the quadratic formula works for every single problem. Yes? I do not have extra batteries, but I do have an extra calculator, so you can borrow the whole calculator. Oh man, somebody already dug through my drawer. I guess I may not. Okay. All right, so hopefully you did x equals -6 plus or minus the square root of 36 minus 4 times something, 1, 3, all over 2 times 1 is 2. Here we go. -6 plus or minus the square root of 36 minus 12, 24, all over 2. Now, if you used a calculator to get it, you'll get a decimal, and you just do it once with plus and once with minus. So, you know, you figure out this decimal. And then what if the test, which it will ask you for both things. It'll say, what is the answer in decimal form? So you use your calculator. And then what if it didn't want decimal form? What's the other form called? Starts with an R. Radical. And this kind can be reduced. Root 24 could be, got an idea? Or do you have a question? You had your hand up for a second. Okay. All right. What do you think? All right. So you'd go root 4 and root 6, and that's really 2. So 2 root 6. Very good. Okay. So then you got -6 plus or minus 2 root 6 all over 2. Do you get that there's something that can cancel now? The 2's. The 2 goes in here and here and here. 2 goes in there once. 2 goes in there once. 2 goes in there 3 times. Final answer. Do I really need to divide stuff by 1? No. So I have -3 plus or minus root 6. All right, and that would also be at the time when, if you wanted to, you could take a calculator right there and just do -3 plus, what's the decimal for root 6? I'll figure it out with the calculator. And then do -3 minus whatever that is. And those are my answers. Yes? How many decimal places should you go to? Generally speaking, 2 decimal places. Generally, you want 2. Like 2.53. All right. So that's just a big kind of overview. Was this in general form? Yes. Could I make it in vertex form if I wanted to? Oh, yes, you could. So I'd like you to do that now. On your remarks app, would you please take this same equation and write it in vertex form? That means do the plus line, minus line thing. This thing. Plus a line, minus a line, 3. Remember that? All right, let me see what you get. Okay. I think you're right. Yes, just finish it, because that's not exactly, you're right so far. It's not done yet. Okay, so now this is the part where you use half and square. The little German boy tells you what to do. Half of 6 is 3. 3 squared is 9, and there we go. And that 3 is positive, by the way. I left that out. It's kind of important, because it was positive up here. All right, and now I can say this and this have to be perfect, as in exactly the same. X plus 3 and x plus 3. That's what would give me that. And then this is minus 6, and then I can put it all together. X plus 3 quantity squared minus 6, and isn't the vertex just screaming, I'm the vertex? Here and here. You get that? All right. Raise your hand if you understand that process. Okay, good. Now, what if I had put this as a 2x squared and this as a 12? I would have factored out the 2 out of both of these, right? And the 2 would have been out in front, and everything else would have been the same, except this 2 also has to go over there. Yes. Okay? Because otherwise I'll have 2 times this 9, and therefore I have to have 2 times that. All right, so then there'll be negative 18 plus 3 would be negative 15. So then your final answer would be a 2 here, and this part here comes out to negative 15. There we go. It's got a new vertex. Okay, so that's the basics of what you've learned so far. Now let's talk about what you're going to learn today. There is notes. If you look under Schoology, you can find the notes so you can follow along, and you won't have to write the problems out. They'll all be on your screen. It'll work pretty nice. So find Schoology, find today's date. Today's November 9th. And find the thing that says notes for November 9th. And this screen will come up. In a moment, I'm going to ask you to show me because I want to make sure you're in the right spot. Don't show me yet. And you're looking under Schoology, you're looking under assignments, you're looking for notes. All right, while you're in there, I'm going to show you something else on Schoology. Do you see, hold on, you won't see it yet. When you first get into my class, you see something new at the very top? Daily video lessons, see that? That hasn't been there before. If you open that, the cool part is that is the lessons right there. Instead of being transported to Yahoo, or sorry, not Yahoo, YouTube, it's right there. And it's the most recent one there, but what if you didn't want that one because you wanted the one from the day before? You see the ones on the bottom? That's where they are. All right, so if you just hover over, I can't hover with my, you won't be able to see it at home, but I'm going to just touch that one, and it tells me, oh, that's discriminant and review or whatever. All right, so there's full screen mode. The red square is because of my recording. So if I go here, I can go to YouTube. I can transport myself to YouTube if I want to go there. All right, so anyway, moral of the story is there's a new folder in town. And again, it's right here, daily video lessons. They're still in the other spot because I didn't want kids to like look for it there and not be able to find it and think I'd not have them up anymore. If I hover with my mouse here over these, it'll hover and say HAHonors 11-7. That's the lesson from the 7th. Here's the lesson from the 8th. Here's pre-calc lesson. Again, you guys aren't pre-calc, but if you were. So anyway, that's how you just keep hovering over these. And if you want to change videos, you can hit this and it'll give you more videos. Hover over them again to see what the names are. All right? Okay, just want to show you that that's an option for a place to get to the video lessons. And now, back to that notes page. If you're here, get there, please. I'd like you to show me right now so I can see who's not showing me, and I know that they're not in the right spot. It's almost everybody is showing me. Keep it up just for another moment. All right, I'm just waiting for one person. All right, good. Thank you very much. Now, hottest place on Earth, just a little factoid. Death Valley is one of the hottest. We're talking hottest place on Earth. So if you want to be the smartest nerd at the party, it's not really Death Valley. Very good. That's a good nerdy answer. sort of like saying how many days are in the year, and you say 365, and the nerd says, no, there's 365, what, 0.25, because it's an extra quarter of a day every 4 years makes a leap year. So anyway, what's the hottest place in the world? Well, in the world would be the core of the Earth, but hottest place on the world, as in on the surface, Death Valley is one of them, but this other place called El Azizi in Libya recorded 136 degrees Fahrenheit, insanely hot. I mean, we've had like hundreds here in Minnesota. I've seen it like 102, but I can't imagine what 136 feels like. But it's a dry heat, so it's really, yes. We happen to be simplifying next, so why don't you turn to the next page? And now, let's talk about this one. I am now talking about this one, so tell me, if I was simplifying that one, is this the kind you're talking about? Okay. All right, go on. Yep. Okay, wait. So if that was a 9, yes, then couldn't I figure out what square root of 9 is? Absolutely. Not a 9, okay. How about it's an 18? All right. You're asking if I can go cancel something in there, and then cancel here too. No, you can't do that. Know why? Because this is all one term. Because it's being multiplied together, it's one thing. And so if there's something in there like an 18, that's a whole separate thing. You could factor this out and like simplify it, like root 18 would be root 9 and root 2, and then that could be 3 root 2. You can do that. But if you're going to cancel, just take 1 from this little group, 1 from this, and 1 from this. All right, so back to what are we doing right now? I'd like you to do this one without me and see if you get the right answer. Just cancel some stuff. See if you get the right answer. Stay with me. Nope, not yet. In fact, on this one, I don't think you need to show me. This one's pretty easy. 3 goes into this twice. 3 goes in there once and once. And dividing by 1 is kind of useless, so we just leave that off. 2 plus or minus root 5. Raise your hand if you know how to do that kind. All right, good. Then we don't need to do the next several slides. Let's go to this one. This is where you're going to have more needs today. And that's about using the graphing calculator to solve more difficult quadratics problems. Do you get that this is a quadratic because it has a little square in it? All right. Now, the fact that it's negative in the front means that it's an upside down parabola, and it's going to look kind of like this. Now, this one's about baseball. Joe Mauer is practicing for spring training by throwing up a baseball in the air and hitting it on the way down. The equation here represents the height of the baseball after t seconds. Notice what we have here is height and time. So this is not a place. It's not a distance. That's actually a time. You get what I'm saying? This is not the ball traveling across the field and landing out in the field. It may look like that, but it's not. This is a graph that the ball is at this height, like right here. After this much time, it is that high. It's about time and height. Okay? So if I give you this spot right here, and I say after 1 second, it is 13 feet off the ground, you get how 1 comma 13 is telling me 2 things? It's telling me the time, and it's telling me how high the ball is. All right, what do you think are important spots? Well, to me, the important spots are where the ball started here, the A spot. How high was the ball when it started? Well, in the real world, is Joe Mauer going to lay the ball on the ground and throw it from there? No, he starts with it in his hand. And his hand is probably what? If you're a normal person, it's probably 3 feet off the ground, maybe. Okay, he's tall, so maybe it's 4 feet off the ground. Okay, so then from there he chucks it up, and this would be like the highest the ball ever goes. That's also known as the vertex. Remember finding vertex form and everything? That's one of the important spots on a parabola. And then the last important spot is right there, not where the ball hits the ground, it's what? When the ball hits the ground. So this might be time of 1 second, 2 seconds, 3 seconds. At 3 seconds, the ball hits the ground. In the real world, did you know it's actually amazingly hard to get something to hang up in the air that long? 3 seconds. You have to throw it insanely high in the air to get it to stay up for 3 seconds. In fact, the longest that a person can stay up in the air is like 1 point something seconds. There's no way you can stay up in the air for 2 seconds. If you jump up in the air and you were able to stay up in the air for 2 seconds, then you have jumped approximately 16 feet in the air. And you can't do it. Okay? It's one of those things that people think, like they see basketball players dunking and they think, oh my gosh, he was up there for like 3 seconds. It might have seemed that way, but unless he jumped 18 feet in the air, no, he wasn't. Oh, I get what you're saying. To try to give yourself more time. You would give yourself a teeny bit more time by landing on something other than your feet, but not much. Like we're talking like a quarter of a second maybe. All right, so we need to get this thing in your calculator before we can do too much more. So what did you write now? Grab your graphing calculator and type that equation right there into your y equals. So it's negative 16t squared. I'll move this over so that we can see my calculator. And I'm going to change it to x too, because you don't have a t on your calculator, you have an x. Plus 25t x plus 5. All right, put that into your y1. I'm going to do that up here. Everybody, I'm telling you, stay with me. You're really going to get lost on how to do this calculator stuff unless you stay with me from the beginning. So negative 16x squared, and again, x is right next to the green button for alpha. And then it's 25 plus 25x. I'm going to delete out that extra x I have in there. And there we go, plus 5. Plus 5. And I hit graph. Now, if your graph doesn't look really pretty right off the bat, like mine looks just goofy, try some different zooms. Oh, wait, back to this. Is anybody having trouble typing this in? Okay. There is. The squared button is off on the side right there. It's the 4th button down on the left. The squared button is right there. Just blacked it in. Okay, how do you do the square root thing? We're not doing a square root, we're doing a squared. The squared thing is this button right here. See it? All right, once you got that in, then the issue is going to be when you hit graph, it probably isn't going to look very nice. And we need to think about this and set our window accordingly. Okay, go to window. And do you get that I need to make this like not as wide? So I need my window only needs to go over for x's. It only needs to go from like, instead of going from 0, I like to go from a small negative number to like, let's say 4. And now set your x min to -2, set your x max to 4. And then hit the graph again and just see what happens. You go, oh, okay, well, that's better. It's now, do you see that I don't need to go up so high? How do I go up higher? I need to go to the windows and set the Y setting. The Y settings right now, I'm going really high. My Y needs to only be like, oh, probably 10. So set your Y maximum to 10. All right, my maximum 10 was probably not quite good enough, so maybe I should make my max a little higher than 10, maybe 15. You see how you just keep playing with it? I'm going to go to Y max 15. We're trying to create the ultimate beautiful graph here. There we go. 0, -1, -2, something like that for Y minimum. All right. So again, if I want to make this perfect, I'd say I still have too much room on my x's. So I need quite that much room, so I can go back to my window, change my x minimum to like -1 and my maximum to like 3. If I really wanted to play with it and make it ultimate, you can. All right, so now, do you get that Okay, I need to pause for a second. Some kids having technical difficulties here. So we're back, and I got pretty much everybody. Looks decent now. Okay, so now this is really important. You're going to use this a lot this year. You're going to use it a lot today for your homework. You're going to use it a lot next year in pre-calc. It's going to be used a lot. And you can use it on the ACT and the SAT tests. They ask you for the minimum and the maximum of a quadratic. It's really simple. What's the highest point here? Do you see it with your eyes? I can see the highest point. It's right there at the top. It's right there. How do I get to that spot? There is a thing called trace, but trace is not the best way to do it. I got to show you the best way to do it. Trace just pulls up a little spider thing, which I can kind of move around until I think it's in the right spot, and then I look at the numbers on the bottom. Okay, that's pretty close, but if you want it exact, here's what you have to do. Everybody with me right now. Second, calculate. Now, which do you think we want if we want the highest spot? Maximum. Maximum is number 4. I'm not going to teach you each thing right now. I'm going to teach you maximum. And now, what is it asking you? It says left bound. You have to go, listen, stay with me or you'll get lost. You have to go to the left side of the spot we want. I'm going to move the little spider over with the left and right keys to the left side of the spot we want. Now it's to the left of the spot I want. I hit enter, and it brings in a little triangle on the screen that says, oh, from here to go to the right side of the spot you want. Anywhere to the right of it. Hit enter. And the last thing it says, guess. Then you go over the top of it and hit enter. So now I'm approximately in the right spot. I hit enter, and it says maximum 0.78 and 14.7. All right. Now, raise your hand if you got that. Okay, good. Those of you that didn't get it, I'm going to do it one more time. Everybody, listen. Shh. If you said you didn't get it, how are you going to get it unless you pay attention? Here we go. Hit second, calculate, which is right above trace. And then I'm going to go to maximum, which is number 4. Go to the left of it. It says left bound question mark. Go to the left of it, hit enter. Go to the right of it, hit enter. And then it wants you to guess. That means you go right on top of where you think it is. And that's close enough. Doesn't matter to be perfect there. And hit enter. And then it says maximum 0.78, 14.76. How many of you have it now? Okay, good. If you still don't have it, you need to get private lessons, which I can do right when we're done with this lesson. All right. So that is the maximum. Now, what does it mean? This is time versus height of the ball. So what is the 0.78? Yes? That's how many seconds? I know it seems weird, 0.78 of a second, but do you get that the ball would reach its highest spot pretty quick? If you're throwing it up to hit it with a baseball, or hit it with a baseball bat, you're going to toss it up. It's going to get to its maximum height pretty quick. Less than a second. 0.7. And how about its height? What was the highest that the ball ever went? 14.7. Okay. So he was apparently throwing it up about 14 feet in the air and letting it come down and hitting it. Okay. And it reached its maximum at 0.78 seconds, and it was 14.7 feet off the ground. So you have to understand that that's time and that's the height of the ball. All right. Next thing that they're going to ask you to do is take the same graph. I'm going to go back to the graph, but just clean it off so it's just my graph. Okay. And do you see this bottom part where it hit the ground right there? They're going to ask you that. That is not where it hit the ground. It's when it hit the ground. Because it's time, right? Just look. Do you see that that's 1 second right there? And this other mark here is 2 seconds. Do you get it's like 1.6 seconds about? 1.7 maybe? Maybe 1.8 the most. So how do you find that spot? That spot is called a 0. It's one of the zeros of my graph. So everybody, right now, hit second, calculate. You see 0? Now it wants me to go to the left side of this. I got to get my spider to the left of the 0 spot. The 0 spot is down here near the x-axis. So to the left of it, but I'm above it. If I'm above it, I'm also to the left of it. Move the spider with the left and right arrows. I am to the left of the zero. Remember the zeros down here. Okay. So I am to the left of the 0 spot. Now I'm going to hit enter. Now I got an arrow to the right, so I can be to the right of that spot. Now I can't even see it anymore, but I know it's to the right of that spot. And the last one is guess. Notice, do you see these little arrow thingies on your screen? That's saying you want me to find the 0 that's between here and here. See what I'm saying? It's saying that between here and here is where you want me to find the 0. And yes, don't talk right now. Yes, that's where I want to find my 0. Now I go guess. That means get the arrow or the little spider thing right on top of the spot. That's close enough. I'm going to hit enter. 1.74. And the y is this weird number which is really, really close to 0. Do you get that 3e negative 12? Means take the 3 and move the decimal 12 spots to the left. So it's 0.000000000000000000 3. Okay, so that's really, really close to 0. So you got to interpret that as meaning pretty much 0. So what's that then? 1.74. We knew our seconds was going to be like 1.7 or so. There it is. That's the time when the ball hit the ground. All right. Now, how many of you are able to get the 1.7419 to come up on your screen? Awesome. That's almost everybody. And those that didn't, you need a private lesson that I will give you in a little bit about how to do this. You need to know how to find maximums and zeros. That's 2 crucial things for quadratics. It comes up on the ACT, the SAT, the MCA test. It comes up on your homework for tonight. It comes up next week when we take the test. It comes up. Okay, so don't just say, oh, I don't get that part, and that's okay. It's not okay. You need to learn how to do this with a calculator because it's going to come up so many times. Finding zeros and finding maximums. All right. So, I think it's time for you to get started. Just talk. Let's talk over this one right here. You type this into your calculator, and then you're probably going to use some either 0 or maximum to get the answer. When would the golf ball hit the ground? Do I want spot X or do I want spot Y? Spot Y. That spot right there. That's when it hits the ground. Because the height right there is 0, and this will be telling me a time. So you'll want to use the zeros thing to get that answer. All right. Now let's start your homework together. Your homework comes from Schoology. If I go to my class, and I don't want to be in video lessons, I want to be under assignments. And if you look for the one assigned on 11.9, which is right here, see that? 7.4 worksheet C, assigned on 11.9. All right, let's start that one together. So you'd open it up, you'd put it into your remarks app. I personally am just going to open it up. Use the quadratic formula or factoring and the ZPP to solve the following equation. All right, so I can just stick this in the quadratic formula. That's going to be an easy one. I don't think you need my help with the quadratic formula. We've done several of those in class. The ZPP is that one where you factor it like this, and you set it equal to 0. Let's say you had 2x plus 1 and x minus 3. Then my answers would be x minus 3 has to equal 0, so x equals 3. Or 2x plus 1 equals 0, so 2x equals negative 1, so x equals negative 1/2. Remember that kind? You solve two little equations. All right, that's the ZPP. All right. Then let's get to the word problem. That's the word that gets challenging because you'll be able to handle all these other ones. Just the quadratic formula. That's easy. So let's do number 7 together. Let me start. The height of a baton after a baton twirler releases it into the air can be modeled by that. Well, I guess you better put that in your calculator. And then they're going to ask you how long is the baton in the air? That's another way to say, if the graph looks like this, when it hits the ground, it tells you how long it was in the air, right? So basically, not the root, it's called the zero. You want to find the zero of this graph, that one right there. Because however long it was in the air, it depends on when it hit the ground. Right, so graph that puppy and find that spot. I'm going to pause for a second while I get that up on my graph. Negative 16t squared. All right, so I've got this little equation into my graph now, and I can see my window's a little messed up. I need to go a little higher. So my y maximum needs to be higher. So instead of 15, I'll go to like 20. Just play with your window until you get it looking really nice. Okay, here we go. And I need this spot right here. It looks like it's about 2. Just because I can see this mark is 1 and that mark's probably 2. I bet it's at 2. But I'll find out by using second calculate the 0. Second calculate the 0 is number 2. And it says left boundary. All right, so I'm going to put in that little wedge on my screen. Be just to the left of it. I am now to the left of it and above it, but I'm going to hit enter. And now I'm going to arrow over a little farther, get to the right of it, hit enter, and then get right on top of it until my spider is pretty much right on it. There, hit enter. 2.02. Nailed it. I thought it was going to be about 2 just from looking, and it's pretty much 2.02. If you weren't around it, you'd probably say 2.03. And there you go. What is that? That's how long the baton was? No. What was that? How long it was in the air. 2.029 or 2.03 seconds. All right. If the baton twirler catches the baton after it falls back to a height of 6 feet, then how long was the baton in the air? Ooh. If she caught it at 6 feet, I'm going to show you a neato way to do that. Hit y equals, and y is the height, right? So y equals what? 6. If I graph y equals 6, that's the level at which she caught it. That's where the height is 6. Now hit graph. You see where she caught it? Didn't she catch it right there? Now you can find out where those two lines intersect. Did anybody ever notice that under second calculate there was also one called intersect? Second calculate. Intersect is number 5. And then it says first curve. Am I on the first line? Yep, I am. Second curve. Am I on the second line now? Yes, I am. And then it says guess. Get right where you want to be. Yeah, it's right about there. Hit enter. And it tells me their intersection is at 1.84 comma 6. What does that mean? Do I have 1.84 lizards in my basement? No. 1.84 seconds. And what's the 6? That was the height. Remember, you wanted to know how many seconds was it when it hit that height? Well, now you know. Okay, so there's some help on how to use your graphing calculator to solve these quadratic